What if the most alien places you'll ever see aren't out in space at all, but hiding on this planet, waiting for you to notice how un-Earth they feel? Scattered across continents are pockets of terrain where light, water, rock, and air behave in ways that make the world under your feet feel borrowed from somewhere else. At Horsetail Fall, you watch a seemingly ordinary waterfall turn, for a few minutes at sunset, into a glowing vertical strip that looks like liquid fire pouring down the cliff. In the Blue Lagoon, you float in warm, mineral-rich, pale blue water while steam drifts over dark lava, and your body relaxes inside a landscape that doesn't look relaxing or natural at all. Inside Sondum Cave, you step through a narrow entrance into a cavern so vast it holds its own jungle, mist, and beams of daylight, like an underground world layered beneath the one you thought you knew. What happens to your sense of normal when you realize these are just 3 moments in a long list of places where Earth already looks off-world? And how different would your idea of this planet be if it were shaped not by familiar cities and beaches, but by 50 of its strangest, most impossible landscapes? If you're ready to see how Alien Home can really look, stay with this journey through 50 impossible places on Earth, and let each one push your idea of reality a little further off the map. Moab. Red Rack Country surrounds Moab with arches and rounded sandstone domes that feel less like landforms and more like the desert's own architecture, curved, hollowed, and improbably precise, as if the plateau has been sketched for millions of years. Those domes and openings are the first invitation, because a walk across slick rock makes the ground read like frozen motion. Wind-built dunes turn to stone, cross-bedded lines that still preserve their direction, and shallow channels where rain has patiently carved the surface back into shape. Following that sculpted terrain deeper, the day naturally shifts into 4-wheel drive country, where off-road routes slide between rock corridors and over tilted ledges, and each bend seems to frame another arch like a doorway cut into the sky. As the hours stretch on, the landscape keeps changing its scale. Wide basins, tighter canyons, higher overlooks, until the pace finally eases into an evening rhythm that favors shade and stillness. That is where camp belongs, close to the Colorado River, with tents under cottonwoods and canyon walls holding the cool air, while the current keeps a steady, low sound through the night. When darkness settles in, the scene pivots from geology to ritual. Controlled fire dancing throws brief, flickering light across the rock faces, turning grain and texture into something that feels alive for a few minutes at a time. The next morning begins with quiet intent, as a yoga session on flat sandstone resets balance and breath in cool air, turning the slick rock into an open-air studio rather than a trail. With that calm in place, the pace shifts to hoofbeats, and horseback rides cross open benches and mesas, where the red rock seems to rearrange itself with every mile, never repeating the same silhouette twice. From there, the day turns upward, with rock climbing tracing cracks and corners on vertical sandstone faces. A hands-on way of reading layers, stress lines, and weathering instead of just looking at them. When the heat builds, motion returns to water, and a rafting run follows faster current and bursts of rapids, trading silence for spray and opening onto wide views of mesas and distant mountains beyond the canyon rims. Just when it seems the place has offered every kind of movement, one last line rewrites the scale. A slack line or high line carefully rigged between two rock walls, where a single steady step turns open air into a route. And when all of it, arches, domes, river camp, firelight, breath, height, and that narrow line suspended over stone, finally settles in the mind at once, Moab stops feeling like a destination and starts feeling like a landscape that was fully lived. Blue Lagoon. Steam hovers over milky blue water, while a black basalt lava field presses in at the edges, creating a scene that looks more like geology on display than a typical soak. Set on Iceland's Reykjanes Peninsula, the Blue Lagoon feels alien precisely because the landscape stays severe, even as the water invites stillness. The warmth is not a natural hot spring in the classic sense. It comes from geothermal seawater associated with the Svartsengi area, where heat and minerals reshape the experience from the inside out. In the bathing areas, the water commonly holds around 100 degrees Fahrenheit, so the body unwinds while the surrounding rock keeps the setting stark and volcanic. That contrast is the real spectacle. Pale water, dark lava, and drifting steam that erases distance until the horizon feels softened, almost edited. The lagoon's signature color is not a trick of lighting. It is silica, a white, clay-like substance that reflects light in a way that produces that unmistakable blue. Follow the silica from the water to the shore, and it becomes a ritual. At the in-water mask bar, guests lift a white silica mud mask and smooth it across the face until skin turns chalk bright. A slow rinse returns the focus to the water's texture, Mineral-rich, slightly opaque, and strangely luminous against the lava, as if the lagoon is lit from within. The mood stays unbroken because an in-water bar serves drinks right in the lagoon, letting relaxation continue without stepping back into the cold air. What remains afterward is the same quiet contradiction that defines the place: a harsh volcanic world at the surface, and a warm mineral bath that makes natural feel newly negotiable. Horsetail Fall. What looks like a modest seasonal ribbon on El Capitan becomes something uncanny in late February, when sunlight finds it at the one angle that makes water resemble flame. Horsetail Fall sits on the east side of the granite wall in Yosemite Valley, and most days it reads as a thin, quiet feature, present but easy to miss. Because the flow depends on winter storms and snowmelt, the spectacle begins with a simple requirement: enough water has to be moving over the rim that day. Then the real condition arrives in the sky: clear air and a late afternoon sun, low enough to backlight the falling water, while the dark cliff behind it turns into a natural screen. For about 2 weeks in mid to late February, that alignment can happen near sunset, and when it does, the fall shifts from silver to a molten orange that looks almost impossible to call just light. Long before the glow appears, crowds gather in the valley with tripods and folding chairs, settling into place like an audience waiting for a curtain that may or may not rise. Small changes decide everything. Thin clouds, haze, or shifting moisture can mute the color, so attention keeps moving between the sky and that narrow strip of water, watching for the moment it commits. When conditions cooperate, the fire look holds for roughly 10 minutes, not as a dramatic stunt, but as a brief optical lock between sun, water, and stone. And as the sun angle slides lower, the orange gradually softens rather than vanishing, easing back toward a more ordinary fall, while the cliff still carries the afterimage of something otherworldly. Grand Falls. A curtain of dark, chocolate-brown water spills over a basalt rim in the painted desert, making the fall look less like a postcard and more like a moving sheet of mineral slurry. Its nickname, Chocolate Falls, comes from the Little Colorado River's extremely muddy flow, which can turn the plunge into a heavy, opaque cascade after storms or snowmelt. The drop is about 185 feet, tall enough to feel out of scale with how remote and quiet the surrounding land can be. This waterfall sits on Navajo Nation land, roughly 30 miles northeast of Flagstaff, where the landscape is wide, exposed, and visually unforgiving. Its origin reads like a geologic interruption. Lava from nearby Miriam crater flowed into the river, created a lava dam, and forced the channel to reroute before rejoining its course at the falls. That backstory matters because it explains why the scene feels impossible. A river redirected by volcanic rock, now dropping through a basalt wall as if the land had been cut and restitched. Access has also become part of the reality. The area has been officially closed to most public visitation since 2023 due to environmental impacts and community concerns, underscoring that this is not an attraction built to absorb crowds. When the water is running, the lasting impression is the same contradiction that defines the place. Raw volcanic terrain, a sediment-dark river, and a waterfall that looks like Earth briefly chose a different set of colors. Sun Dong Cave. A narrow jungle entrance leads into darkness, and then it opens almost immediately into a space so vast, it feels as if the ground has been carved into a private sky. Hidden inside Phong Nha Ke Bang National Park, Sun Dong Cave is widely recognized as the world's largest natural cave by volume, and its interior scale is exactly what makes it feel off-world. The main passage stretches nearly 6 miles, with sections rising more than 650 feet high, dictions that turn cave into something closer to an underground landscape. That landscape formed slowly. An underground river exploited fractures in ancient limestone and widened them over time until entire chambers took shape around moving water. Inside, the ceiling does more than hang overhead. It helps build the cave, as mineral-rich drips deposit calcite into stalactites, flowstone, and towering stalagmites that look poured into place rather than carved. Then the structure breaks open in places, where collapsed skylights, dolines, let daylight spill into the darkness and allow vegetation to establish a self-sustaining pocket of green inside stone. Where light and water overlap, mist layers gather and drift through the chambers, sometimes thickening until the interior can resemble clouds moving beneath a roof of rock. Travel through these sections is guided and tightly controlled, with river crossings and, when water levels require it, brief passages by a small boat or raft, while guides explain the cave's geology, hazards, and history of exploration. What lingers afterward is not only size, but structure, a place with its own weather, its own greenery, and stone formations that make the interior feel like a world assembled beneath the world above. Cave of the Crystals. Deep inside the Nika mine in Chihuahua, a plain rock tunnel opens into a chamber that looks engineered out of glass, massive, translucent beams crossing the air at every angle. This is the Cave of the Crystals, a limestone cavity famous for giant selenite crystals, the clearest form of gypsum grown to an almost architectural scale. The cave exists where heat from below and mineral-rich groundwater created the stable conditions needed for crystals to keep growing instead of dissolving or breaking into smaller forms. Over long spans of time, warm fluids stayed close to a delicate chemical balance, allowing slow, continuous growth that favors fewer crystals, but far larger ones. For much of its natural life, the chamber was flooded, which helped protect the crystal surfaces from drying, cracking, and sudden temperature swings. When mine pumping lowered the water table, the cave became accessible and immediately revealed why it had been hidden so well. The air can reach about 136 degrees Fahrenheit, with humidity so high that the body cannot cool itself normally. Because of that extreme microclimate, entry has been tightly restricted and the site is not open for ordinary visitation, both for human safety and to reduce damage to the formations. In geological terms, the alien effect is straightforward. Common minerals, common water, and uncommon stability. Yet the result feels like a natural cathedral built from time, heat, and chemistry. What makes it unforgettable is the contradiction at its core. A fragile crystal world that can only exist where conditions are harsh enough to keep almost everything else out. Panjin Red Beach. What reads like a shoreline dyed crimson is not sand at all, but a living wetland that turns red when the salt marsh plants mature across the tidal flats. Near Panjin in Liaoning province, this red beach sits in a river delta landscape of shallow coastal waters and tidelands, where the ground is shaped as much by tides as by soil. The color comes from Sueta salsa, a seepweed adapted to saline alkaline conditions, an ecosystem detail that explains why the red looks so uniform and so unreal. Because the terrain is flat and water-bold, the red spreads like a continuous carpet rather than appearing as scattered patches, making the horizon feel artificially painted. Reed marshes and estuary channels surround the red flats, turning the scene into a transition zone between river and sea rather than a conventional coast. That same transition zone is also an ecological stronghold, protected as a nature reserve and recognized for supporting large numbers of wetland birds, including rare species. In the end, the alien effect is simple and geological at heart. Tides lay the stage, salt conditions set the rules, and a plant built for extremes supplies the color. Sea cliff of stone plates. Along Vietnam's central coast, a low headland of dark rock steps into the sea in stacked plates, so orderly that the first impression is not erosion, but construction. This formation is known as Gan Da Dia in Phu Yen province, and its strangeness comes from a single idea repeated thousands of times: basalt columns packed together like a stone mosaic. The story begins with lava spreading across the shoreline, still hot enough to behave like a fluid sheet, then cooling fast as it met air and water at the edge of the ocean. As that lava hardened, it did not simply become rock. It contracted, and contraction forced it to crack along natural stress lines into tight, polygon-like columns, rather than breaking into random blocks. Over time, the surface was planed and revealed by the coast itself, as waves kept finding the seams between columns, rinsing away weaker fragments and polishing the tops into flat faces. That is why the structure reads like plates. Many columns have broad, level caps, and the slight changes in height create terraces that look stepped, as if the shoreline were tiled and then gently shifted. Up close, the geometry becomes the main spectacle, because edges meet edges with surprising consistency, and the eye starts recognizing a repeating pattern instead of a conventional cliff. Yet the pattern is not perfectly uniform, and that variation is part of its realism. Some columns lean, some split, and some lock together at angles that reveal how cooling and cracking fought for control in the same moment. Basalt's naturally dark metallic tone deepens the illusion, because the rock absorbs light while the ocean throws it back, making the boundary between stone and water look high contrast and almost graphic. In practical terms, the site is compact, roughly about 220 yards long and about 55 yards wide. Yet it feels much larger because the repeating texture refuses to break into ordinary shoreline clutter. What makes it rare is not that hexagon-like columns exist in the world, but that here they are exposed at the ocean's edge in such a continuous, walkable field, where the sea keeps maintaining the pattern instead of burying it. And when tide and light slide across the surfaces, the headland stops reading like a cliff and starts reading like a blueprint. Proof that the planet can produce something that feels designed simply by cooling, cracking, and time. Waitomo Glowworm Caves. A river disappears into limestone, and the darkness ahead begins to spectral like a night sky that somehow formed underground. In the Waitomo region on New Zealand's North Island, long-buried marine limestone was slowly dissolved by moving water, opening chambers and corridors in classic karst fashion. That same water still shapes the experience today, guiding the route through smooth-walled passages, dripstone textures, and quiet pools where the cave feels more like landscape than tunnel. Overhead, mineral-rich drips have left the familiar signatures of limestone caves, delicate formations built grain by grain, so the ceiling reads as a record of time rather than decoration. Then the mood shifts from geology to biology because the stars are living. The New Zealand glowworm, Arachnocampa luminosa, which produces a blue-green light during its larval stage. The light is part of a hunting system, with fine, sticky threads suspended in the still air, turning the grotto into a quiet, working ecosystem that only looks like pure magic. The most iconic moment comes on the underground stream itself, where tours move by boat beneath the glowing ceiling in near silence, letting the scale of the darkness do the talking. Long before it became a modern attraction, the cave's first well-known exploration is tied to an evening of candlelight and a handmade raft, when Maori chief Tane Tinarau and surveyor Fred Mace entered and encountered the glowworm grotto. What lingers afterward is the layered logic of the place. Stones shaped by water, chambers decorated by minerals, and a living canopy of light that makes the underground feel impossibly vast. Red Singi. A bowl of scarlet spires rises from pale ground like a field of petrified flames, each thin ridge and needle catching the light in a way that makes the earth look freshly forged. In northern Madagascar's Diana region, the Red Singi sits inland from Antsiranana, roughly about 37 miles to the south, in a river-shaped landscape rather than a coastal one. Despite the name Singi, this is not the hard, razor-gray limestone seen elsewhere in Madagascar. It is red laterite, iron-rich soil and rock whose natural chemistry produces deep reds and oranges. That color reads like pigment, but it is simply iron oxides concentrated in the ground, then exposed as erosion strips away softer layers. The form comes from water as much as from chemistry. The Iroto River system cut channels into the laterite over time, leaving behind narrow pinnacles, ribs, and fluted walls that resemble a carved amphitheater. Instead of one cliff, the site feels compact and intimate, with repeated gullies and ridgelines creating a tight geometry that looks designed rather than purely weathered. What makes it feel almost alive is that the structure is still changing. Laterite is softer than limestone, so wind and runoff continue to recut edges and reshape the needles after each season. Movement is typically managed on foot with local guiding, reflecting how easily fragile laterite textures can be damaged or collapsed if people scatter across the formations. In the end, the red Singi proves the off-world look can come from ordinary ingredients: earth, iron, and flowing water, arranged into a pattern the brain does not expect to see on a normal day. Lencois maranhenses. A white ocean of dunes stretches to the horizon in Lencois maranhenses, where the ground looks like water frozen mid-swell and the sky feels unusually close. Along Brazil's northeast coast in Maranhão, this landscape forms in a narrow band between the Atlantic and inland wetlands, shaped by wind as much as by geography. Its sand arrives and renews itself through a coastal system fed by regional rivers and currents, then reorganized by trade winds into long, clean ridgelines that keep migrating. What makes the scene feel truly unearthed is what happens between those ridges. Because the low corridors are not just emptiness, they become basins. During the rainy season, fresh water collects in the troughs and lingers, forming temporary lagoons that appear impossibly clear against the white dunes. The effect is a natural optical contradiction. Desert textures underfoot, yet water everywhere in pockets, reflecting clouds like small mirrors scattered across the sand. Over time, the dunes continue to shift, but the seasonal water returns again and again, as if the landscape resets itself on a schedule written into climate. Even the colors behave strangely here, with bright sand amplifying light while the lagoons deepen it, turning simple blues and whites into something almost graphic. Despite its vastness, about 600 square miles, the place feels intimate because every ridge creates a new frame, and every basin hides a different patch of water. Lencois maranhenses leaves a precise impression, a coastline where wind builds the architecture, rain supplies the surprise, and desert stops meaning what it usually means. Salar de Uyuni stretches as a white, blinding plain so flat and uninterrupted that the horizon can feel like a line drawn with a ruler. On Bolivia's high plateau, this salt desert formed from the drying of ancient lakes, leaving behind a vast crust of evaporite minerals where water once stood. The surface is built from hexagon-like salt polygons that repeat for miles, a natural pattern created as the crust expands, contracts, and recrystallizes. In the rainy season, a thin film of water can spread across the flats and turn the salt into a mirror, erasing depth and making sky and ground trade places. Covering about 4,086 square miles, it is one of the largest salt flats on Earth, yet it can feel less like a landscape than like a controlled experiment in light and distance. Salar de Uyuni leaves a simple, alien conclusion. Geology can be so uniform and so reflective that surface becomes hard to define. The Red Beach in Fujian Lake, Yunnan. A strip of rusty red sand runs alongside water so clear and blue that it reads like two different planets agreeing to share one shoreline. At Fujian Lake in Yunnan, the scene sits on a high plateau, about 5,645 feet above sea level, where crisp air and hard light sharpen every boundary. What makes the red feel especially unreal is that it is not a bloom or a seasonal plant stain. Descriptions point instead to iron-tinted sands and soils gathering along the edge, a geological imprint rather than a living one. Online images often push the saturation into neon territory, but even when the hue is softer in person, the contrast still looks wrong in the best way, like oxidized pigment brushed onto glass. It is the simplest kind of impossible. Ordinary minerals, ordinary waves, and yet the meeting of red sediment and deep blue water makes Earth feel like it quietly rewrote its own palette. White Pocket sits on the remote Paria Plateau like a spill of melted stone. White domes, red bands, and swirled layers that make the desert look briefly unrecognizable. Inside Vermilion Cliffs National Monument in northern Arizona, the setting is high, open, and spare, with a kind of silence that makes color and texture feel louder than distance. The rock here is Navajo sandstone, built from ancient dune fields, and the curving stripes still read like wind frozen into a solid surface. What makes the place truly strange is the way those dunes were later distorted and reworked, leaving contortions and bulges that feel less like layering and more like motion captured mid-turn. Across the same outcrops, reds can fade into pale stone because iron pigments that once colored the sandstone can be chemically mobilized and removed under the right groundwater conditions, bleaching sections toward white. Erosion then takes over as the editor, cutting the deformed sandstone into rounded domes, small fins, shallow gullies, and potholes that collect rain and briefly mirror the sky. The result is not one landmark, but a continuous field of patterns, where every step changes the geometry and the horizon never settles into a single, normal shape. Reaching it is part of its character, since the access roads are deep sand and rough rock, and land managers explicitly warn that high-clearance four-wheel drive is required to avoid getting stranded. In the end, White Pocket feels alien for a simple reason. Familiar desert sandstone, afflicted by chemistry and deformation, then sculpted by erosion into forms that look designed rather than weathered. Deadlie sits like a white, sealed basin in the Namib, a clay pan so bright and bare that the surrounding dunes feel exaggerated, almost unreal by comparison. Near Sossusvlei inside Namib Naukloof Park, the setting is defined by a constant negotiation between wind-built sand and the rare directional force of water that once reached this low ground. Its story begins with the Sauchab River, which in wetter phases flooded the depression just long enough to leave shallow pools and damp sediments behind. That temporary water was enough for camel thorn trees to establish themselves, turning what looks like pure desert today into a place that once carried a small, functioning wetland. Then the balance shifted, not with one dramatic event, but with a slow takeover, as dunes advanced and gradually cut the basin off from the floods that had kept it alive. With no replenishing water, the clay floor dried, hardened, and effectively sealed, becoming a pale surface that reflects light instead of absorbing it, like a natural stage set. The trees died when the supply disappeared, yet the remains still stand as dark, sculptural trunks because the air is so dry that decay slows to a crawl. Many accounts place their death roughly 600 to 700 years ago, which gives the scene a severe kind of time depth. Life ended, but evidence stayed. Around that stillness, the wider desert does not become empty so much as selective, with hardy organisms surviving on fog, morning moisture, and rare rainfall rather than dependable streams. The visual logic is almost clinical. White clay, black wood, orange dunes, blue sky. So the mind reads the place less as scenery and more as contrast reduced to its essentials. What makes it feel off-world is the way familiar cues of comfort and scale fall away, replaced by emptiness so clean that every footprint looks temporary while every tree looks permanent. Deadlie's final impression is not death, but process. Water created a pocket of life, sand removed the supply, and dryness preserved the outcome with almost laboratory clarity. A small hillside of sand ripples in reds, browns, violets, and ochres so cleanly separated that it looks like the ground was dyed in layers rather than weathered. The 7 colored Earths sit on the Chamarel Plain in southwestern Mauritius, a compact set of dune-like mounds that became famous precisely because the colors hold their boundaries. Geologically, the material traces back to volcanic bedrock, basalt that broke down into fine clay-rich soils under intense tropical weathering. The palette comes from chemistry more than artistry, with iron-related minerals driving warmer reds and browns, and aluminum-related compounds contributing cooler, bluish, and purplish tones. One of the most unusual traits is that the differently colored sands tend to settle into distinct bands instead of blending into a single brown, creating a striped look that feels almost engineered. Rainfall then acts like a sculptor, cutting fine rills and shallow grooves into the exposed surface, so the site reads as both a color phenomenon and an active erosion landscape. What makes it linger in memory is the simple, alien logic. Ordinary volcanic rock, extreme weathering, and steady erosion combining into a terrain where soil behaves like a layered mineral display. Cappadocia. Soft volcanic rock rises into towers, cones, and rippled valleys that look sculpted by design, as if the land was poured and then carved while it cooled. In Cappadocia, central Turkey, that unreal geometry begins with ancient eruptions that laid down thick beds of volcanic ash and tuff, later cut and sharpened by wind, rain, and freeze-thaw cycles. Over time, the erosion favored the strangest shapes, fairy chimneys, and stone fins, where harder caps protect weaker rock below, letting pillars survive while the surrounding ground falls away. Because the tuff is workable, people turn the landscape into shelter, carving homes, storage rooms, and entire underground networks into the hillsides to hide, survive winters, and outlast danger. Rock-cut churches and monastic spaces followed, where carved interiors kept a stable climate and frescoed walls carried centuries of faith into the stone itself. Above ground, the same valleys that look alien also function like a natural amphitheater, with ridgelines and corridors that make distance feel close and silence feel amplified. Cappadocia's power is the way geology and human history share one material, volcanic rock shaped first by the planet, then by people, until the boundary between landscape and architecture almost disappears. Reflection Canyon curves through red sandstone in a tight, almost calligraphic bend, where still water turns rock into a mirror and makes the shoreline feel deliberately drawn. It lies in the Lake Powell backcountry within Glen Canyon National Recreation Area, near the Escalante River arm, far from roads and ordinary overlooks. That setting matters because Lake Powell is a modern reservoir, created when Glen Canyon Dam began holding back the Colorado River in 1963, and it flooded side canyons that were already carved into the plateau. The canyon itself is the older story, sandstone shaped by long erosion, cut and recut by runoff in ancient streams, then partially reused by the reservoir as water rose into the bends. As levels shift, pale mineral bands and exposed shelves trace former shorelines along the walls, turning the rock into a readable record of change instead of a static backdrop. Reaching the viewpoint is intentionally demanding, typically a remote dirt road approach followed by a long, unmarked backcountry hike, so the place keeps a sense of distance even in the age of famous photos. What lingers is the quiet contradiction at the center of the scene, an engineered lake occupying an ancient canyon, producing a geometry so clean it barely feels accidental. The Dead Sea lies in a long, sun-bleached trench where the land has pulled apart, and the result feels less like a lake and more like a geological scar filled with light. Set between Israel and Jordan, it occupies the lowest part of the Jordan Rift Valley, a landscape defined by steep margins, bare slopes, and a horizon that always feels compressed. Its defining trait is not color or cliffs, but chemistry. This is a terminal basin with no outlet, so minerals concentrate as water evaporates and salts accumulate over time. That concentration changes how the surface behaves. Buoyancy becomes effortless, and the water carries the body in a way ordinary lakes cannot. Along the margins, crusts of salt can form into angular shelves and brittle patterns, turning the shoreline into something that looks manufactured rather than natural. Behind those salt edges, the ground tells a quieter story of instability, because shifting water levels and dissolving underground salt layers can trigger sinkholes that open without warning. The surrounding terrain amplifies the alien effect. Pale sediment, sharp rock, and heat haze flatten the distance until the lake appears to sit inside a stripped-down, almost lunar palette. At more than 1,300 feet below sea level, the basin's depth in the landscape is not just a fact. It is a feeling, as if the world has been tilted downward and held there. For centuries, the Dead Sea's minerals have been treated as a resource as much as a curiosity, linked to salt, bitumen, and therapeutic mud in the region's human history. That human footprint remains visible today in extraction works and resort zones, where an ancient landscape is asked to serve modern industry and modern leisure at the same time. Yet the larger narrative is still written by climate and evaporation, because the balance between inflow and loss determines how the shoreline enhanced or retreats across the salt flats. What makes the Dead Sea unforgettable is the way it compresses the planet's rules into one place: rifted earth, concentrated minerals, unstable margins, and a body of water that behaves like it belongs somewhere else.